Howdy folks, and welcome to our first lesson on congruent triangles. Just some vocabulary you need to know. Congruent polygons are shapes in which all the corresponding or matching sides and angles are congruent. So for this picture we've got here, corresponding angles would be like A and E. They are in matching positions. I've color-coded it to make it a little easier to see. And when you write a congruence statement, that's just you describing which two polygons are the same size. And the order that you write the letters in is going to be really important. So for instance, the congruent statement for this shape is ABCD is congruent to EFGH. You could also write it as like BCDA is congruent to FGHE. That's totally cool. It's just that the matching or corresponding letters have to be in the same position. So when it asks you to complete the following statements about the figure above, you can do that by looking at the picture or by looking at the congruent statement. So by looking at the picture, I see AB and EF in the same spot of the congruent figures. So AB has to be exactly the same size as side EF because they're matching parts of congruent shapes. And I could also tell that by looking at the letters in the congruent statement. So like if I wanted to say, oh, what letter or what side or angle matches up with C? When I go up here, I see C is the third letter and G is the third letter in the second part. So angle C and angle G must be the same size. I want you to try to complete the other 6. Pause the video and then unpause to see if your answers are correct. How'd you do? Okay? Cool. If you have questions, bring them to class. More vocabulary. An included angle is the angle that's formed by two sides of a polygon. An example that we're going to look at is angle A is the included angle between side AB and side AC. So all that's saying is like here's AB, here's AC, A is the one that's in between them. We've also got an included side, which is the side in between two angles of a polygon. So for example, AB is the included side between angle A and angle B. So like here's angle A, here's angle B, here's AB, the one in between them. Moving on to our most exciting event for the day, the big 5 postulates. These are the different ways that we can prove two triangles are congruent, or same size. So we actually just have to check a couple of things to know if two triangles are going to be the same size. We can check if they have all 3 sides in common. So if all 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles have to be the same size. So for instance, in this example over here, I see they have AB and DE the same size. Those 2 little markings mean BC and EF are the same size. And then the 3 markings mean AC and DF are the same size. So each triangle has a side, and a side in common. Then we've got other ways. Side, angle, side. If you've got 2 sides and the included angle of one triangle congruent to 2 sides and the included angle of another triangle, then they've got to be congruent or the same size. So like triangle number 1 here has a side, the same as one of the ones over here, an angle, the same as one of the ones over here, and a side, the same as one of the ones over here. So by SAS, we could say that those 2 triangles have to be the same size. Third one, angle, side, angle. If 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then those 2 triangles have to be the same too. So when I look at this triangle, it has an angle with 1 little hoop on it. So does this one. It has a side with 1 little mark on it. So does this one. And then it has an angle with 2 little hoops on it. And so does this one. So triangle ABC and triangle DEF must be congruent, or exactly the same size as each other, by ASA. 2 more, dos más. Angle, angle, side, or AAS, is if you have 2 angles and the non-included side of one triangle, the same as 2 angles and the non-included side of another triangle, then those 2 triangles have to be congruent. in the picture, the biggest difference between AAS and ASA is that the side that they both have isn't like right between the angles, it's kind of off to the side. So we've got an angle, and not the side in between them, but a side off to the side, AAS. Last one, hypotenuse leg, and this is cool because it's only for right triangles only. So just as a review, if I look at my right triangle over here, that little box means 90 degrees. The side that's across from the 90-degree angle is called the hypotenuse, which I'm going to abbreviate for now, just says HYP. And the other two sides of the triangle are called the legs. So the theorem hypotenuse leg says that if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then they've got to be congruent to each other. I'm going to erase this stuff really quick. So when I look over here, I see that they both have a hypotenuse with one little mark on it. They both have a leg with one little mark on, or two little marks on it, and they're both right triangles. So by hypotenuse leg, they've got to be congruent. I'm going to do two examples here with you, number 1 and number 2, and then I want you to try out 3, 4, 5, and 6 with the video paused and then unpaused to see if your answers are right. Here we go. Identify which congruence postulate applies, and then write a congruent statement. The congruence postulate is one of the big 5, and then the congruent statement is the thing with the letters that says which two triangles are congruent. When I look at my first triangle, I see an angle, that same angle's over here. I see a side, that same side is over here, and then an angle. That triangle has the same angle. So I would say the postulate that proves they're congruent is ASA. Congruent statement, triangle ABC is congruent to triangle, let's see, A matches up with Y, and then B and X match up, C and Z match up. So there's my congruent statement. You could have the letters in a different order if you wanted to, as long as the corresponding ones match up. Number 2, which postulate? I see an angle that they have in common. I'm skipping over a side to another angle, and then I got a side off to the side. So this one is AS because they don't have a side in between them in common. It's the side that's kind of off to the side. My congruent statement, let me maybe erase my little marks here, see what's going on. Let's see, R goes with M, Q goes with O, and P goes with G. So there's my congruent statement. Again, I want you to pause the video, try 3, 4, 5, and 6. 5 and 6 are tricky. Then unpause the video and see how you did. Come to class with questions. Alrighty, so let's check your answers, see how you did. Whoa! Number 3 should be hypotenuse leg because it's a right triangle. Triangles 4 should be side, side, side. Down at the bottom, it's a little tricky. On number 5, these two triangles actually share the side PQ. So side, 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 side. This one, number 6, is also tricky. You might be like, oh my God, there's not enough information. We see a side, and actually, because of what we know about vertical angles, we can add some little hoops, add some little marks to the two in the middle and know that they would be the same. So we see a side, an angle, and a side for both. Again, come to class with questions. See you then.